Here a power supply busbar arrangement has been shown. As it is a three-phase system, all the isolators are three phases and two-part supply. Electricity needs reliability. That means interruption must be minimum. Alternate part supply must be arranged. Especially for railway, the incoming supply interruption is not welcomed. So we are normally using 100% standby, means everything will be two in numbers at least. Suppose this power supply, we are taking power supply from A and B, two grid sources. Two grid sources we are taking power supply, and we will at a time use only one power supply, but any problem or for any maintenance or other thing we can switch over one one to another. Suppose B is giving power supply. If it is required, then we can switch on to A by first isolating the B. But if you do this thing, extend in relay, we are extending feed during this period to another TSS, adjacent TSS in the overhead conductors. And relay system, mainly we are using two phase, but nowadays it is 2 into 25 kV. Due to this 2 into 25 kV system, we are using three phases. Scott connection is using all the three phases in the transformer, but in open delta we are using alternate two phases in three transformer. There are three power transformer and alternate phases we are connecting with. Suppose the first transformer is red and yellow, the second transformer will be yellow and blue, and third will be blue and red. This is alternate, but transformer is single phase transformer, means phase and neutral, but we are not using neutral, we are using two phases in the open delta system. So it is now in use in railway, this 2 into 25 kV system. So here we have shown three phases, but it is not accurate in the railway system. Just a conception, for some conception how we are doing these changes and everything, it has been shown. Suppose you will take power supply from B. Black means it is in discharge condition. The supply is not available. Now you have to take power from B. A and B's incoming supply is available, but we are not taking power now. Now first we will take power supply from B. How? See. Now to get power supply from A, switch off B. How? How will switch off B? You can open the first isolator of the transformer side of the B way. Then, but before that, you have to close the isolator transformer side, the second isolator. If the phase sequence and parallel running of the two, this isn't possible. If it is not possible, then a power interruption is must to change over this. Normally it has not been done. Without power supply interruption they are changing. First they are changing the power supply of one transformer, then the other, so that one transformer can give the power supply. But how to achieve this? Simply you keep switch on the first isolator of the transformer side and don't close the isolator between two transformer. Then the power supply of B will feed one transformer. Next, now you charge the A feed, A side isolator, so that the power supply will go to the second transformer. Now what will you do? You will switch, change over the power supply from B to A. How? You open the isolator of the transformer side first isolator, but before that close the, not to close, then you close the bus coupling isolator of the two transformer. Then both the transformer will be charged for parallel running. And if it is not required parallel running, then it's very simple. One transformer always will be in circuit, but in relay generally we are using one transformer, but during overload we can make it parallel. Now the transformer capacity is too high, so in relay system we are feeding one side with one transformer and another side with one transformer. In between the two transformer the overhead system is insulated, so that bridging is not possible because there is phase difference in the Scott connection and also in open delta connection. But it is the basic system I have shown to change over the power. Later I will show you how in the Scott connection and in open delta connection we are changing over the power supply. The facilities on neutral section. Neutral section is provided in front of the TSS so that not to bridge the two transformer output. There is a phase difference. Here I have some three phase output. It is not for relay, but in relay it will not be the three phase. For Scott connection, two output each of the transformer will come out, and in open delta two transformer will always feed one transformer on one side and another transformer on one side, but it is also two terminals, not three. But I have shown here three because it is not for relay, it is to give you simple idea. Then I'll come to the railway system. So what is the brief? Brief is our electricity for industrial area and railway is must be reliable. That means interruption as far as possible to be avoided. So this standby system, if any interruption on any bay, other bay will feed and there will be no interruption or minimum power interruption, not to affect the railway traffic movement and the industrial production. So this is the system. Now we'll switch over from B to A. See how. So we have seen that power supply is possible both from A and B, and another bus couple kept between A and B, because if A supply fails, then we can extend the feed from B. If the isolator is defective close to the first transformer of B bay, so that feed can be extended via the A bay to the transformers. These all alternating arrangements. Any problem, we can maintain the reliable power supply.